Hi, I'm Chem's best friend. I make chemistry easy. I'm a graduate of MIT, and I have more than 17 years of experience teaching AP chemistry and chemistry classes. Please like and subscribe to my channel. And if you are interested in private tutoring lessons, the information is on the screen. Hi, in a previous video, we learned about differences between ionic and molecular compounds. But in order to understand chemistry very well in your future studies, we need to understand what happens when we put these compounds in water. Very important thing to understand. So let's learn about it. Let's go to my screen. Before we answer the question, what happens when we put ionic and molecular compounds in water, we need to understand the difference between these two terms. What does dissolve mean? And what does dissociate mean? Many times, students don't even pay attention to these two words. They use them interchangeably, but they cannot be used interchangeably because they really mean two different things. So, what does dissolve mean? When I think of dissolve, I'm going to say dissolve means can a compound or an ion, can it swim between water molecules? Can it swim between water molecules? And what does dissociate mean? Well, dissociate mean comes apart, right? Breaks apart. So for us, dissociate will mean can it break apart into ions? So dissociate breaks apart into ions. Now we're going to see how these terms apply to real life. Let's first focus on molecular compounds in water. What are some examples of molecular compounds that you know? Probably the one that you know the most is sugar, sucrose. The formula for sugar is C12H22O11. Another molecular compound that is very common is oil. Okay, let's think about sugar. Does sugar dissolve in water? Well, of course it does. Think of a juice you drank, any type of baking you do, all the sweet things. They are sweet because sugar dissolves in water. Well, what about oil? What happens when we put oil in water? Well, you know even a famous saying, oil and water don't mix. So oil does not dissolve in water. Well, let's look molecularly what happens. Here in the first picture, we have an example right here of ethanol molecules in water. And here you can see here are specific individual ethanol molecules, and they swim between water molecules. This is, ethanol is in beer, wine, alcoholic drinks can also be used as disinfectant, but here it is, it can swim between water molecules. The same thing will happen with sugar. Sugar molecules will stay intact, nicely all together, and swim between water molecules. On this picture, this illustration, you can clearly see what happens when you put oil in water. Oil swims on top. Oil and water don't mix. And here are some different examples of different oils or other molecular compounds that do not mix with water. So, how could we summarize this? Well, when I think of molecular compounds, I'm going to say 50%, around 50%, half and half, 50% do dissolve in water, but around half of them do not dissolve in water. So it just has to be with what type of compound you have. Okay, let's go a little next. Let's see what happens when you put ionic compound in water. Well, some ionic compounds are not soluble, so they will just not dissolve at all. But many of them, actually probably most of them, are dissolved. They do dissolve in water. What happens when you put salt in water? Well, you know that salt will dissolve in water. You might live next to an ocean, Atlantic Ocean or Pacific Ocean, and you know it's salty. That's your proof. Salt dissolves in water. How does it do that? Well, let's look at the picture. Here is a salt dissolved in water. It looks clear. But what happens? Well, when you put a salt crystal or an ionic crystal in water, the water molecules attack it and break that lattice apart. So individual ions break apart. So here is another also a beautiful example of ionic compound being breaking apart between, by water molecules. So in order for an ionic compound to dissolve in water, it has to dissociate into individual ions. So the ions separate and then swim between water molecules. Wow, it's pretty cool. Next, let's talk about electrolytes. What do you think electrolyte is? Well, maybe you do sports, and after lots of running or a big race, your coach says, drink Gatorade, replenish your electrolytes. Why do they do that? What's going on? Well, electrolytes, it's a substance that when dissolved in water can conduct electricity. Let's write that down. So what are electrolytes? They can conduct electricity. Electricity in water. Okay, and in order to be an electrolyte, in order to conduct electricity, you need to have two things. Two conditions have to be met. If they are not met, it's not an electrolyte. So the two conditions that have to be met, you need to have charge, and this charge has to be able to move, movement. These are the two things that have to happen. So let's talk about molecular compounds, electrolytes. Well, here is these two green, this diatomic molecule represents ethanol. So when you put ethanol in water, let's review quickly. Here is ethanol swimming between water molecules. Did it break apart into ions? Do you have charge? No, there is no charge. There is movement between these two plates and between my electrodes. There is movement, but there is no charge. So therefore, molecular compounds cannot conduct electricity. They are not electrolytes. Drinking sugar water after your race will replenish your energy, but it's not going to help your muscles recover. Let's look at this picture. What happens when you put an ionic compound in water? Well, in order for ionic compound to dissolve, it has to dissociate. That's what we said. It dissociates into ions, and individual ions have charge. So here, if you put potassium chloride, you have ions swimming between. Oh, I have charge and I have movement. I have two things. Two conditions are met. So my ionic compounds are very strong electrolytes, and you can see that the light bulb is brightly lit. And then here comes the third example. What is going on? Acetic acid, that's vinegar. That's a molecular compound, and the light bulb is a little bit very dimly lit. So it is an electrolyte, but not strong. Wait a minute, what's going on here? Let's talk about a special case of molecular compounds. Molecular compounds which are acids. Acids are a special case of molecular compounds that when put in water, they dissolve into ions. They give off an H+. That's a definition of an acid. So molecular compounds that are acids, when dissolved in water, will break apart into H+, and it's anion. And because they will, if H+ is a charge and an anion will be negative charge, they can conduct electricity. So I think we should now summarize everything that we learned, make it a really nice chart, and summarize what we learned. So let's first start talking about ionic compounds. So we have ionic compounds. Some of them, so let's make an arrow here, make an arrow here. Those of them that are not soluble they will not dissolve, they will not dissociate, and they are not electrolytes. But those that are soluble ionic compounds, what happens? They will dissolve in water, right? So table salt, sodium chloride, they will dissolve in water. How will they dissolve water? They will dissolve in water by dissociating, by breaking apart into individual ions, which can then swim between water molecules. You will have movement and charge. So they are electrolytes. They can conduct electricity. Next, we talked about molecular compounds. And we said that some of them are not soluble in water. So some of them are not soluble. They do not mix with water. These are like oil. Well, what happens? They do not dissolve in water. They do not dissociate. They are not electrolytes. Other types of molecular compounds, like sugar or ethanol, are soluble in water. So what happens? They will dissolve in water, they will swim between water molecules, but they will not dissociate. And therefore, there's also no charges. They don't break apart into charges. They are not electrolytes. However, there is a small group of molecular compounds, which are acids, which absolutely can dissolve in water, like HCl or acetic acid, vinegar. And how do they dissolve in water? In order to dissolve in water, they give off its H plus ion. So yes, they dissociate. Acids dissociate in water and forming H plus cation and its negative anion. And that means that they can conduct electricity via electrolytes. So here you have a beautiful table, whole summary between ionic compounds, molecular compounds, what happens when you put them in water, and are they electrolytes. So thank you for watching, and I hope you learned something new.